All right. We are going to look at radians and degree measures. The objective is to describe angles by using radian measures, degree measures, and we're going to use angles to model and solve real-life problems. So an angle is determined by rotating a ray about its endpoint. The starting point of the ray is called the initial side. So that's that endpoint is the vertex. So wherever we start is the initial side. And then the position after rotating, so we're rotating this direction on this example. This is what's called the terminal side. All right, we're going to be using this terminology throughout this unit. In a coordinate plane, an angle is in standard position when its vertex is at the origin and its initial side coincides with the positive x-axis. In other words, we're in standard position when our initial side is the positive part of, you can't see that, part of the xy coordinate. Positive angles are generated by counterclockwise rotation. So if I tell you to graph a positive 135 degrees, you're going to start at the initial side, which is on the positive x coordinate, and you're rotating counterclockwise 135 degrees. Negative angles are generated by going counterclockwise. So we start at the positive x and we rotate clockwise to get our negative 60 degrees. On the test and quiz, I'll ask you to draw an angle. What's important is you show me how you rotated, what direction you went, because this one here could also be a positive angle going this way. Okay, so you've got to show me the direction. You've got to show me the terminal side also. The measure of an angle is determined by the amount of rotation from the initial side to the terminal side. Angles can be measured in radians or degrees. And we all know that rotating all the way around a circle gives us how many degrees? 360 degrees. You know that from geometry. Questions there? One radian is the measure of a central angle theta that intercepts an arc S in length to the radius of the circle. So theta radians is S divided by R. An angle of 1 revolution is 2 pi radians. What do I mean by 1 revolution? One all the way around the circle once. An angle of half a revolution is halfway around, which is pi. A fourth of a revolution is pi over 2, and a sixth of a revolution is pi over 3. So here we have an XY coordinate grid, and I've got some things labeled in it. Theta starts at 0. We've got quadrant 1, quadrant 2, quadrant 3, quadrant 4. That goes all the way back to at least algebra 1. You all know that the XY axis makes a 90-degree angle. You know that's a 90-degree angle, which is pi over 2. So angles in quadrant 1 are positive angles between 0 and pi over 2. Angles in quadrant 2 are between pi over 2 and pi. Angles in quadrant 3 are between pi and 3 pi over 2. And angles in quadrant 4 are between 3 pi over 2 and 2 pi. So these kind of helps us out there with that. Angles between 0 and pi over 2 are acute angles. You know that acute angles measure less than 90 from geometry. You also know that obtuse angles measure between 90 and 180, which is between pi over 2 and pi. We're going to be dealing with mostly radians in here. Questions there? Okay, coterminal angles are angles with the same initial and terminal sides. These are considered coterminal. Example, the angles of measure 0 radians and 2 pi radians are coterminal. Because that means, well, 0 radians means I don't rotate at all. But 2 pi radians means I start here and I go 360 degrees or 2 pi. I also land right there. To find an angle that is coterminal to a given angle, add or subtract whole numbers that are multiples of 2 pi, multiples of that 1 revolution. Questions here? Find and sketch 2 coterminal angles that are 7 pi over 6. I guess we ought to get example. There we go. So what did I just say? How do we find coterminal angles? We add or subtract what?
Whole number of 2 pi.
It was just right here at the bottom. It says to find an angle that is coterminal to a given angle, add or subtract multiples of 2 pi. Right there. So for this one, we can add 2 pi. And then we can subtract 2 pi. Guess what you're going to learn to like? Fractions. So how do I add fractions? What do I have to have? Common denominator. So what's our common denominator here? 6. So 2 pi is the same as what over 6? 12 pi. So we get 19 pi over 6. This one here is going to be 7 pi over 6 minus 12 pi over 6. What is that? Negative 5 pi over 6. Terminal side is right here. Where is 7 pi located? 7 pi over 6? Well, that's what? That's 1 1/6 pi, right? So 1 pi is where? Right here. Well, this is a half a pi. Where's pi over 6? Is pi over 6 going to fall before a half a pi? I'm graphing this one first. So that's 1 1/6. This is 1 all the way down. Here's a half. So a 6 is going to be somewhere right in here. So there's 7 pi over 6. How do I get to 19 pi over 6? Well, 19 pi over 6 equals what? 3 1/6 pi. So I've got to rotate 3 pi and then a 6. So we're going to go 3 pi is going to be what? Starting here. There's 2 pi, right? There's 3 pi. There's a 6th pi. It's the same graph, except what did I show here? I showed that I went around 2 pi's. Went around rotating. All right? So that you have to show that. If I ask you to graph 19 pi over 6, you've got to show me where you've rotated 19 6th pi's. What about this negative 5 pi over 6? They're the exact same graph. They are coterminal, except what's different about them? It's just the rotations. All right, and then negative 5 pi over 6. Well, if this is a 1/6 of a pi, where's 5 pi over 6 going to be? It's going to be the same spot. It's going to be right here, except we rotated downward, and it's a negative 5 pi over 6. Okay, these are coterminal, meaning we're going to land the same where we go. It's just how we get there is different. It's just like, what if 3 of your friends live on the same block? One of you go out the door and you head east and around the block. Your buddy lives right next door to you, goes out the door and heads west and around the block to get to your friends that's on the other block. You end up at the same place, right? Just one of you went a different route than the other. That's what's happening here. Questions there? So B, how are we going to find 2 coterminals? We're going to add 2 pi. We're going to subtract 2 pi. Common denominator is 4. So how do I write 2 pi with a denominator of 4? 8 pi. Which gives us 5 pi over 4. For the second one, I can use this same 8 pi over 4, but subtract it. So let's do the first one, negative 3 pi over 4. We always start right here. And then I'm going to rotate a negative 3/4 pi. Where's that going to fall? Which quadrant? Which one? The second? The third?
It's gonna go around.
I'm doing negative 3/4 of a pi. So I'm rotating what direction?
Clockwise.
We're rotating clockwise. This is a whole pi. So 3/4 of it, this is a half a pi. So 3/4 actually falls right here. Five pi over 4. That'll land the same exact spot. Well, 5/4 is what? That's 1 1/4, correct? So I've got to go, and I'm going positive, so I got to go 1 whole pi and another 4th. We're landing the same place. And then negative 11 pi over 4, we're rotating this way. And 4 goes into 11 how many times? 2. So that's 2 3/4. So there's 2 right there, 3/4 right here. You need to show your arrows, need to show your direction, need to show all this. I know when I grade the tests and the quizzes, some students just draw this and they just draw the line. They don't show me what direction they rotated. They don't show the rotation, and they lose points for that. Questions there? Chrissy, you good? Complementary and supplementary. Same definition as what was in geometry. Complementary angles add to what? 90 degrees. Supplementary add to 180. In this case, then their positive angles are complementary if their sum is pi over 2. Two positive angles are supplementary if their sum is pi. If possible, find the complementary and the supplementary of the given angles. So for A, pi over 6. I want complementary, so how do you find complementary? Pi over 6 plus what? So pi over 6 plus what angle equals pi over 2? So you take pi over 2, subtract pi over 6. So we have to have a common denominator. What is it? 6. So this is 3 pi over 6 minus pi over 6 equals what? 2 pi over 6, which reduces to pi over 3. If they're complementary, they have to add to 90. So I take, or pi over 2 in this case. So I took pi over 2 and subtracted pi over 6 from it. Common denominator. If I'm going to find the supplement of it, what do I subtract it from? Subtract it from pi. Supplementary, add to 180 or pi. Common denominator 6. So we get 5 pi over 6. You guys try B. So what angle added to 5 pi over 6 gives us pi over 2? I hear someone saying a negative number. But in order for them to be complementary, it needs to be what? They need to be positive angles. So this number, 5 pi over 6, isn't that bigger than 90 degrees? It's bigger than pi over 2. So it does not have a complementary. It's already larger than 90 degrees, so we do not have a complementary. And then for this one, pi minus 5 pi over 6, that's 6 over 6, gives us pi over 6. Questions there? Well, you're going to need to be able to convert between degrees and radians, radians and degrees. We know that 2 pi radians equals 360 degrees. You also know that pi radians equals 180 degrees. So to convert from degrees to radians, multiply by pi over 180. To convert from radians to degrees, we multiply by 180 over pi. And those of you that have taken physics, chemistry, you've done conversions. When you want, if like this is 60 degrees, all you have to remember, guys, is that pi and 180 are equal to 1. And so this is 60 degrees, so I have to put the degrees on the bottom so that what cancels out? So the degrees cancel, and that's going to leave us with radians. And I can divide 60 by 1 and 180 by 60 to get pi over 3. And if you go back and look at that unit circle that we did on Monday, at 60 degrees, we had pi over 3. And again, on your unit circle test tomorrow, you will not have time to do all these conversions. 320 degrees times pi over 180 degrees. The degrees cancel. 320 and 180, they're both divisible by 10, so I can cross off those zeros. And I can divide them both by 2. I get 16 pi over 9. And then the negative 30 degrees. Again, multiply that pi over 180. And we leave our answers in pi form. The degrees cancel, and I can divide 30 by 1 and 180 by 30. And that gives me a negative pi over 6. If you remember from the unit circle, 30 degrees was pi over 6 radians. What? All right, then at the bottom, we're going to convert to radians. Radians to degrees. That means we're going to multiply by 180 over pi. What happens to the pi's? They cancel out. And we get 180 divided by 6, which is 30 degrees. We just had that up here for B, or for C, 30 degrees was pi over 6. So 5 pi over 3, I'm going to multiply by 180 over pi. Again, what happens with the pi's? They cancel. 3 goes into 180 60 times. So that gives us 300 degrees. That should be on your unit circle too. Anytime you're given angle measures that have a pi in it, that unless it says 5 pi over 3 degrees, it's radians. In this case, it's just a number 3. If they just, and it's 3 radians. So how do I convert 3 radians to degrees? Well, just like you did the other ones. You multiply by pi, by 180 over pi. In this case, you're going to get the calculator out. You're going to go 3 times 180 divided by pi. And you should get 171.887 degrees. Again, it's going to be a rounded answer because of that pi. Questions there? Yes.
We aren't able to round up with this, are we? Like, we have to be that specific.
Yeah, I would do at least, I'll tell you, but yeah. It's not a whole degree, so we don't want to list it as a whole degree. Questions? All right, then we have 2 formulas. One is the area of a sector. For a circle of radius r, a central angle theta intercepts an arc of length s, given by s equals r times theta. And what's important? Am I at the wrong? There you go, arc length. Sorry. We're at arc length. formula is S equals R times theta. The important thing is that theta is measured in radians. So if I give it to you like this example, radius is 27 inches. Find the length of the arc, but the central angle is 160 degrees. So what do I have to do with theta before I can plug it into this formula? I have to put it in radians, which means I have to multiply by pi over 180. So is that 8 pi over 9? Divide them both by 2. So our arc length is going to be 27 times 8 pi over 9. Put that into your calculator. What I did was, though, I saw that 9 went into 27 3 times, so that gave me 24 pi. Which gives us about 71.398 inches when you put it into your calculator. You don't have to. You can just stick it in your calculator and get the answer.
So if he wrote 24 pi, would we get that off?
Well, we're going to want, because if you're telling someone the length of something, and you tell them 24 pi, they're going to go, what? Whereas if you tell them 75, they have a better understanding of what 75 inches is. So yeah, when we're talking about length, we're going to want to multiply it out. Unless I say, give me the exact answer. But I'm not going to on these. Okay. Then the last one is the area of a sector. By the way, you'll need to know these formulas for your test. By the way, the test is a ways away. Even though I remind you about these formulas the day before a test, these two problems, which I think are the easiest on the test, they're the ones that are missed the most because you guys don't study the formulas or you don't think about it. So make a little side note if you have to. For a circle of radius r, the area of the sector with the central angle of theta is given by area equals 1/2 r squared theta, and again, theta is measured in radians. So we're area equals 1/2 r squared theta. They told us r is 75. They told us theta is 135 degrees. So do I just square that and multiply by 135? Nope, this needs to get converted into radians. One 35 reduces to 3 pi over 4. Put that into your calculator and see what you get.